Welcome to our Math 154 videos. In this video we're going to discuss graphing some functions with specific properties pertaining to our absolute and local maxes and mins. So our first example here, we have a function that is continuous on the closed interval -2 to 3. So we have to make sure our function is defined everywhere, including -2 and 3. And we want it to satisfy these four properties. So let's take a look at the first one, absolute minimum at -1. So that means when we hit our x value of -1, there's some point down here that is the lowest our function ever goes in this interval. So we're just going to call that point, let's say A1. So we're going to use our maximum, or absolute minimum is going to be A1. Then our absolute maximum we're going to call point A2, and that's going to be at 3. So when we hit x equals 3, there's some point up here, call it A2, and that's going to be the highest our function ever goes in this interval. So now all the other values we have need to be between those two heights. Okay, so we can't go any lower than A1, we can't go any higher than A2. Now we have a local maximum at 0. So when we hit 0, we get a local max, so that looks something like this, right? The derivative is going to be 0 right there, but we have a local maximum. So let's call that B1. So we have a local maximum B1 right at 0. Now we have a local minimum at 2. So what's that going to look like? It's going to look something like, I guess we'll put it here. Right, so I could raise or lower this if I wanted to, as long as it's a local minimum. So it can't be any lower than A1, but it could be higher or lower. Alright, this is just one function that satisfies these properties. We could have a bunch of different ones. So we're going to call this point B2. So now we have all four of our properties, and the function needs to be continuous. So it needs to be defined at every value between -2 and 3. So all we really have to do is connect this all together so that it becomes a continuous function. Now it's a little bit shaky, but as long as it's continuous, we're actually good. So we're going to do that. It's actually defined at 2, and there we go. We have a function that's continuous from -2 to 3. We've got an absolute maximum at A2. We've got an absolute minimum at A1, and we have a local max and min at the values we wanted. So this function satisfies our properties. So here's our second example. We need to sketch the graph of a function with 2 local minima, 1 local maximum, 4 critical numbers, and no absolute maximum. So note that a critical number is a place where the derivative is 0. So the derivative is 0 at our local minima and our local maximum. So we already have 2 local minima and 1 local maximum. That's going to give us 3 of our 4 critical numbers. So let's maybe just place those on our graph. So let's say we have a local maximum here, right there. We can have a local minimum right here, and we'll just go ahead and connect that, and we could have a local minimum down here as well. Alright, so now we've got our 2 local minima, our 1 local maximum, and we have 3 of our critical numbers. So we're going to need to do a 4th one. So a critical number is a place where the derivative equals 0. So if we continue our function up and have something like this, and then our function continues to increase, at this point right here, we're going to get a derivative of 0. So you can see if you tried to draw the tangent line in there, it would be 0. So that's going to give us our last critical number. So now our 4 critical numbers, let's label them C1, C2, C3, and C4. There's our 4 critical numbers. Now we don't want the function to have an absolute maximum. Well, that's really easy to get around because we didn't have the criterion that our function is continuous. So we don't need to have a continuous function. So I'm going to draw an asymptote here, and we're going to have the function just increase forever. So that way there could never be an absolute maximum because there's no point where our function reaches a max and comes back down. It's going up forever. So now we have 4 critical numbers. 2 of them are C1 and C3, are our local minima, and C2 is our local maximum. So we have a function f, we'll call it f, that satisfies these given properties.